Fire. Right.
Yeah, I guess welcome to the CBE 6 review. I'm Megan, and this is Caroline.
Hello, I'm Caroline.
I'm not remember.
Cool. Okay, so these are the topics that CBE 6 looks at. We're doing a lot of stuff with equations, slope, and finding equations of lines. And then we also looked at transformations and solving systems of equations. So linear equations, are lines that look like this. So linear, it means like the highest power is 1. So that's like most of the equations we deal with in this class are linear. So it means it's just like a straight line.
Not like a parabola.
Yeah, exactly. So, and then if we want to find like a certain point, we can like find the x and find how it relates to the y, or we could do the other way around. Okay.
Oh, yes, okay. Let's do this first one. We want to graph this linear equation, but first we need to get it into a form and so that we can like interpret it better. So do you know a better form that we could put this
Y
in?
equals mx plus b.
Yeah, let's do y equals mx plus b. Okay, so let's try and get the y all by itself. So I'm going to, let me rewrite this here. Okay, I'm going to subtract the x over. So now I have 5y equals negative 10 minus x. And then I'm going to divide both sides by 5. Okay, so now I have y equals negative 10 divided by 5 is negative 2. And then I'm just going to put this as a 1/5 in front, minus 1/5 x. That's the same as x over 5. Okay, so now I can graph this because I have my y and my x here, and I have the slope, and then I also have the y-intercept right here, the negative 2. All right, so let's graph first the y-intercept. So if we plugged 0 in for x, we're going to get this negative 2. I'm going to plug this here. And then the way that I always remember slope is rise over run. That's perfect. Okay, so here we're going to rise negative 1. So we're going to go down 1, and then we're going to go over 5. So I'm going to go down 1 over 5. I'm going to plot this one here. Okay, and then I'm just going to do that again, down 1 over 5. Okay, and I don't need to do too many points here, and then I can just like draw a line through all of these. Oh wow, that wasn't a very good line, but you get the point. Is we can just plug in like if we can at least get that y-intercept, then we can figure out the slope from there, and you don't have to have the specific points. You can just figure out the slope.
Yeah.
Coolness. Do you have any questions about that?
That tracks.
Right. Cool. Okay, slope of a line. Okay. So the slope of a line is, we just barely talked about it, is how much we're changing in the y direction and how much we're changing in the x direction. And so we can, if we only have the points, we can use the equation of the difference. So this would say, like, if we have our little graph here, if our y2 minus y1 subtracts these two distances from each other, so it only gives us the distance between the 2 points. And the same idea with the x.
Okay.
So we can subtract how far across it is in this x direction and how far across it is here, and subtract those, and it only gives us the distance between the two of them. Okay, yeah, that's basically the equation for slope. And then just make sure that you don't get the x2, x1, like those flipped, because that can be kind of confusing.
How do you tell which one's which?
So like
The bigger one?
so say you had like 1, 2, and then you had like 4, 5.
Yeah.
I can just say like this I want to be my x1, y1 and I want this one to be like you can
Just
just
make sure you don't accidentally like x1, y2. and
yeah.
X.
But like if you have 2 points, you can just like pick which one. Like say this is gonna be the x1 y1 and this is gonna be the x2 y2 and then just stay consistent
Okay,
with what
just
you
make sure that they
picked.
pair up with it.
Yeah.
Okay, yep.
All right.
Cool. So here's a practice problem with that. So I'm gonna say this one is 2 and this one is 1. It could be the other way though, it doesn't matter. So we want our y2 minus y1 over x2 minus x1 to get our slope. So we take our y2, that's this negative 5/4, minus our y1 is this negative 4, so plus 4, over x2 is this one, minus x1 is minus 1/2. And now we just have to simplify this down. And one thing to make sure is like your top column, like these two right here, that's your 1 point. Well, I guess it's this one. And this other column is this other point. So if you make sure the points are like lined up that way, that's another way to double check.
Okay.
So I'm gonna rewrite this 4 as a 16 over 4. You okay with that?
Yeah, yep.
Okay, so negative 5 plus 16, we get 11/4 over, I'm going to rewrite this 2 as 4/2. 4/2 minus 1/2, 3/2. And so we kind of have this like double fraction thing going on. Do you remember how to fix that?
Like, no, I would have to show me.
Okay, cool. Yeah, this is like CBE 4 or something. It was a while ago.
Times them by each other?
Yeah,
Multiply that?
yeah.
Okay, yeah.
Yeah, so.
So 11 over 4 multiplied by 2 over 3.
Mm-hmm.
Okay.
Yeah, exactly. So.
I just took a second.
Yeah, so we want to
I haven't
multiply.
been in class at all for CBE 6, and so I didn't know if there was like some rule that you were like.
Oh,
I
no.
was like,
No, that's all good. Yeah, so when we're dividing fractions, we can multiply by the reciprocal, which is what you said. So flip the second one. So that gives us 22 over 12, which we can take a 2 out of both of those, which gives us 11 over 6.
Perfect.
Okay. Any questions on that one?
Nope, that makes sense.
Cool. Okay, so equations of a line, we already kind of did it, but there's like 2 forms that we talked about. There's this slope-intercept form, the y equals mx plus b. For this one, you need a slope, which is your m, and you need to find the y-intercept. Then point-slope form, you need to find a point, which is this y1 and x1, and you also need the slope. So either way, you're going to need the slope, but then you can kind of choose which one is more convenient, I guess.
Okay. So with we're gonna use that equation that that we just saw. Okay, we're gonna do the y minus y1 equals m x minus x1. Okay, so first I'm gonna find the slope. So I'm gonna find that m. And to find m, I'm going to do the y2 minus y1 over x2 minus x1. So let's find that one first. I'm going to choose this is my x1, y1, and this is my x2, y2. Okay, so if I just plug those in for the my y2, y1 values here, I have 9 minus 6, and then over 8 minus 3. Okay, so I get, oh no, don't show us yet. Okay, I have 3 over 5, 3/5. Okay. Okay, so now I have my m. So and then my y1 and x1, like if you plugged in the x2, y2, like if you plugged in the other point, it would still give you the same answer. So, but we're going to just plug in the x1, y1 since we already decided that one. But you can plug in any point that you know is going to be on the line. Okay, so I'm gonna have y minus 6 equals 3/5 x minus 3. Okay. And then I can put it in slope-intercept form. I think if it's going to ask for slope-intercept form. It is. All right. So I'm going to subtract. Well, first I'm going to distribute the slope into my parentheses. I'm going to get 3/5 x minus 9/5. 9/5. Okay, and then I'm going to add this 6 over to both sides. So I'm going to get y equals 3/5 x minus 9/5 plus, and then 6, if I get it with the same denominator, this is 30/5. That's the same as 6. So that I can add those two together. So in the end, I get y equals 3/5 x plus 21/5. Okay, perfect. Okay, problem 4.
So, and I think the CBE, if it asks for slope-intercept form, you can like put in that form. But if it doesn't say, you can put point slope form.
Okay.
So yeah, yeah. If it doesn't specify, it doesn't matter.
Sweet.
Okay. So now here's another one. So let's just try the same thing. So if we do find their slope, I'm just gonna say this is 0.1, this one is 2, just to make it simpler. But okay, so y2 is 1 minus y1 is 7, and then x2 minus x1 is plus 6. That gives us 8/0. Do you see any issues?
Yeah.
Yeah, what's wrong with that?
Dividing with 0.
Yeah, this is not allowed. So this gives us an undefined slope. Do you know what that looks like? It's kind of weird.
Is it a straight line?
Mm-hmm.
Yeah.
It is a straight line, yeah. So we'll have something like that. So now we just need to figure out where our straight line is. Do you have any guesses?
See if I can- At. No, I don't got it now.
Okay. Yeah, that's okay. Let's put our points on this little picture and see if we can figure it out. So we have -6. I'll just say that's 6.
I didn't see that.
Yeah, there you go. Perfect. So that one would be like right here. So it would be like right here.
Yep.
Yep. So the x in both of them is -6. So we just have x equals -6. Any questions on that one?
No, that makes sense.
Okay. And I don't think there's one in this slide, but if you got like something like 0/8, that would be like our y equals.
Okay.
Because 0 slope is like this flat line.
Yeah.
Okay.
Okay, so in this one, we have a line, and we want to find a new line that's parallel to it. And remember, if two lines are parallel, it just means that they have the exact same slope. So let's first find the put this one into y-intercept form so that we can figure out what the slope is, and what we would need to change so that it contains 0, 3. Okay, so I'm going to solve for y here. So I'm going to have, I'm going to move that, I'm going to subtract 9x on both sides. Okay. Okay, and then I'm going to divide by -2. Okay, so let's plug this point in and see if this point is on this line, or whether or not we need to change this equation so that it's parallel to it, but it contains our new point. So if I plug in my x, I'm going to get y is equal to 3/2, which is not what we want. That means that for this equation, we get 0 and 3/2, which we don't want. We want 0, 3. So do you know what we could do to change our equation so that it contains our new point?
We're looking for 0 and 3.
Mm-hmm. That's the point we want the line to contain, with the condition that it's parallel to this line.
Multiply by 2, right?
Yeah, you could multiply our slope by 2 to get it. That's one way. The main thing that I always forget when I'm thinking about parallel lines is that the slope needs to stay the same, but we can just change the y-intercept however we want. So if we, 3/2 times 2 is 3. So, but if I multiply this by 2, I'd get a -3, which isn't exactly what you want. But I can I can change my y-intercept. So I'm going to have y equals 3 plus 9/2 x. Because now when I plug 0 in, I get y equals 3.
Okay.
Do you have any questions about that?
So you're good to just change it? I guess I don't quite understand that one.
Okay. Do you have a better explanation for how they do that?
Yeah, so thing is, like, with parallel lines, the slope is what's the same. And
Yeah.
like here, these both intercept the y-axis at a different spot. So like in our y equals mx plus b, so our slope, the m has to stay the same, but we can change this b to whatever we want. Like we can move this line up and down. Like if we moved it like right here, it'd still be parallel.
Okay.
Yeah, so how I usually do it is I just do like y equals, and then we put our slope in, whatever we got, and then we can put our point in and try to solve for b to figure out where we want it to cross.
Okay.
Like this one, it gave us the y-intercept, so we knew it was 3, but if it didn't, like, this next one, it doesn't give us the y-intercept. So, I guess first let's find our slope. And it says perpendicular. Do you remember, like, what relationship perpendicular slopes have?
The intersect, no.
Yeah, so they do, like, look like that.
Mm-hmm.
Yeah, so, yeah. The slope of, like, I guess if a line has a slope of 2, the perpendicular line, we take the reciprocal and make it negative. So, like, the slope of 2 will be perpendicular to a slope of -1/2.
So just like exact opposites to one.
Mm-hmm.
Yeah.
Yeah, so first we want to find the slope of this line, so then we can make them opposite. So I'm just going to do the same thing we did in the last problem, put in slope-intercept form. So subtract 4x. Then I'm going to divide it by 2. So y equals 3 minus 2x. So what's our slope in this line?
What's the slope?
Yeah.
It's down 2 over 1.
Yeah, so it's this -2.
Yep.
And yeah, it's over 1, which will help us when we try to flip it. So we flip it and then make it negative, which then makes this positive. So yeah, so we want our slope to be 1/2. So then we have a slope and a point. So we can either put that in slope-intercept form and solve for b, or we can just put it in point-slope form.
Okay.
Which do you prefer?
Let's solve for b.
Okay. Yeah, both methods will work. So
I just want to see that.
okay, yeah. So y equals m, which we found was 1/2, x plus b. And then we have 3 variables in here, and we want to find 1. So we can just put this point in to find what b is. So our y in here is 5. So 5 equals 1/2 times this -4 plus b. And then, so 5 equals -1/2 times, and normal 1/2 times -4 is -2 plus b. You add the 2 over, you get 7 equals b.
Okay.
Yeah, so then we can go and put this back. So we get y equals 1/2 x plus 7. Does that way kind of make sense?
Yeah, it does.
Okay. Okay, so next we have transformations. And what it means by that is, in other classes you might like stretch out graphs, but in this one we're just gonna like take it and like slide it around almost. So like, here are a lot of the functions we'll look at. Like linear, we were looking at like lines, straight lines. Parabolas, this is like, we get like that kind of shape. Square roots, they kind of look like a sideways parabola that's cut in half, is how I usually think of it. And absolute value, we get like a little V shape. Those are supposed to be straight lines.
Yeah.
Okay. So then shifting, it's like if we had, I'm going to use our V shape, we could move it to be like down here. You see how we kind of just slid the whole thing down? Or we could also slide it left to right. So horizontal shifts, this is kind of a weird, like confusing way of saying it, but like this, we might have our absolute value and we have like a -3 in there. So that will like shift it 3. So horizontal, it kind of feels backwards because this, it seems like it should be left 3 because it's -3. So it seems like we should be going 3 this way.
What's an absolute value?
Yeah, yeah. And even if we have like a square root, it will still be going right.
Okay.
It's kind of weird, but the way that Janet explained it is like, for equation we have y minus h equals something with x. I guess they're using c in this one. So in this, c is how much shift we get, and h is how much up and down shift we get. But a lot of times you'll see it written like this. You see that that's like the same? Yeah. So that's why this one, because we added it over, now it seems like more correct, like we move it up and down. Like up is positive, down is negative. But if it was on this side, it would also feel backwards. Does that kind of make sense?
Yeah.
It's really weird. Like,
Yeah.
I don't know how to
The
explain it.
logistics make sense.
Yeah.
How you move it.
Yeah, is weird. So so reflection, if we have like a negative, so like if we put a negative right here, that will make our V like upside down. So it flips it over to x, which will be like, over the x is like right here, so if we have like this shape, it will flip it like the other way.
It reflects it.
Mm-hmm. Hit.
Okay, so here we have that square root function. So let's draw our before graph of the square root. So we have, this is our square root function. Okay, so now we have this new one, and so how are we going to transform this one? Okay, so first, let's start with the inside of the square root and see what it's going to do. So before, do you remember what we do for the horizontal? Because here we have x plus
55.
the horizontal. This will be our vertical shift.
That's the vertical. Okay. So then the plus 72.
Mm-hmm. Sometimes how I remember it is when we have y equals mx plus b, this b tells us how much we're going to move up initially. So this like plus 55 tells us how much we're going to move up, but then we shift it over in the x direction. Okay, so first we know we're going to go up 55. So we know it's up here at 55. Okay, so that one is the one that doesn't feel wonky. So now we have to do the one that kind of feels the opposite of what it's supposed to do, which is the 72. So because it's inside of that square root, and it's plus 72, we're going to move it to the left. 72.
Okay.
Sometimes it's
So in a square root function like that, if it was negative 72, you move it to the right 72?
yeah.
Okay.
Yeah, so now we have our function, and now it starts here, and it goes and it does that same square root function. So we're moving up 155, and we're moving to the left 72.
Okay.
Yeah, because like when you talk about it conceptually, like you're gonna move it opposite of what you say you're gonna do. Is kind of like, what is going on? But it's easy to see the pattern once you do a couple examples.
Yeah. If it's always opposite, that's really.
Yeah. Okay. There you go.
Okay, so this one's kind of the opposite of what we just did. It gives us the picture and asks us what changed. So I guess, yeah, let's list what changed. So our normal picture, this is an absolute value of x.
Yeah.
And that looks like our little V shape. So what's different in this one?
What's different than the absolute value of x?
Yeah, so what did we change in this
Well,
one?
it's reflected and then
Yeah.
it's up 7 and then I guess it would be negative 4.
Yeah, and then, yeah, so this
No,
point's
wait, I'm
kind of
sorry,
confusing, but
yeah, up 7, negative 2. I was going
yeah, there you go.
Yeah, that's good.
Yeah, so it goes right 2, which you're absolutely right would be a negative 2 inside. So we have our x minus 2, which is this right 2. And then up 7, we do plus 7. And then how do we make it reflected? That's okay.
I don't remember what it was. What
Yeah.
was it that reflected?
So what we want to do is just make
just
it
make it
negative so
okay.
it flips
Yeah.
it. Cool. And that's what we got. Okay. Any questions on those?
No, that makes sense.
Okay.
Okay, I'll talk about systems equations.
Okay.
Okay, so here we are looking, we have a bunch of different equations, and we're like trying to solve where the two equations cross, or we're just like, or we're trying to solve for variables. Systems of equations can help with all of those types of questions. Okay, so I think it's good if we just see an example. Okay, so here we have y equals negative 3 fifths x plus 1, and then 2x plus 3y equals 2. So we want to know, like, at what point, what x and y makes both of these true at the same time.
Yeah.
And there's a couple of different ways we can do it. We can do it by graphing, substitution, elimination. Do you have like a preference for which one you would like to do?
What's your favorite? What's that you think is easiest?
I mean, I don't feel as though there is an easiest one. I mean, like if you had a computer to graph it, that'd usually be pretty easy.
That one is the easiest.
I usually like substitution. Substitution usually works pretty well for me.
Okay, let's do it.
Okay, so first, mainly because here we already have this y equals. So if I plug this straight into this y, all of a sudden I have only x's, and I can just solve for x, which is super nice. Okay, so I'm gonna do that. So I'm gonna do 2x plus 3, and then negative 3 fifths. The only thing with substitution like this is that, like, if your equations are long and you have to like distribute, like I have to distribute this 3, is that it can become a lot. So sometimes elimination, but usually substitution works for questions like this. Okay, so I'm gonna distribute my 3 here. So I have 2x plus negative 9x over 5, and then plus 3 equals 2. Okay, so now I'm going to combine my x terms. So I'm going to get a common denominator, and I'm going to get 10. So this turns into 10 over 5x minus 9x over 5 plus 3 equals 2. Okay, so now that's just x over 5. 10 minus 9 is 1. Plus 3 equals 2. All right. And I mean, I could have subtracted that 3 over right at the beginning, but like you can kind of do this in whatever order you want to do. So I'm going to subtract that over now. So I'm going to have x over 5 equals -1. And then so x equals -5 when I multiply that 5 over. Okay, so now that I have my 5, I can just plug that into either, and you can plug it into either one of them. Do you have a preference for which one we should plug it into?
The top one.
All right, let's do that. Okay, y equals -3/5. Okay, and I'm gonna get negatives cancel out, the 5s cancel out, 3 plus 1, so I'm gonna get y equals 4.
So it's -5, 4.
Huh?
Is
Yeah.
the answer,
Yes.
right?
So sorry. Yeah. So you're going to get at the end. I'm going to get -5, 4. Good point. Okay, because we have both of these. Great. Yay. Okay. Go ahead.
Cool. Okay, so do you want to see another substitution or do you want to see elimination?
Yeah, do elimination.
Okay,
I understand substitution. That's it.
yeah. So yeah, and I feel like this one's set up better for elimination.
Yeah.
So how elimination works is we want to add the equations together to get rid of something. So here it's really nice because if we add them right now, the y's will get rid of each other. But you might have to like multiply one of the equations by like 2 or something just to make something be opposite. So here if we just add straight down, we have 5x minus 4x is 1x. Then y minus y is just 0 y's. So and then 0 plus 4 is 4. So x equals 4. And then now what do we do with that?
We can just plug that in for x.
Mhm. Yeah. Do you want to do the top or bottom?
Bottom, why not?
Sure. Okay, so we have -4 times x is 4 minus y equals 4. So we have -16 minus y equals 4. Then we can add 16, 20, and then, yeah, we can multiply both by -1. So then these make each other positive, so y equals -20.
Sweet.
Cool. Okay, any questions on elimination? Yeah, so that one can be faster if they're set up nicely like this, but substitution I feel like works well on any problem. So it's kind of a pick and choose.
It's like a choose your own adventure every time.
Awesome.
Yeah.
Love that.
Okay, so yeah, do you have any other questions?
No, that covers it. Thank y'all.